Welcome to a lesson on the parametric representation of a solution set for a linear equation. We should already be familiar with linear equations in the form of, let's say, y equals 2/3 x minus 2, which is a slope-intercept form of a line, as well as 2x plus 3y equals 12, which is a standard form of a linear equation. But to define a linear equation more formally, a linear equation with n unknowns, x sub 1, x sub 2, all the way through x sub n, is an equation that can be put in standard form or this form here, where x sub 1, x sub 2, all the way through x sub n and b are real numbers. The a's are called the coefficients, and b is called the constant term. Notice the a's are being multiplied by the unknowns, and b is the number without the variable. A solution to a linear equation is a set of all real numbers, c sub 1, c sub 2, and so on, such that x sub 1 equals c sub 1, x sub 2 equals c sub 2, x sub 3 equals c sub 3, and so on, satisfy the given linear equation. The set of all solutions is called the solution set, and to describe a solution set for a linear equation, parametric equations are often used. A parametric equation is a way of defining a relation using parameters or other variables. And then finally, a linear equation with n variables has n minus 1 free variables, or variables that can take on any real value, which will assign the parameters or their variables to. Let's take a look at an example. We want to solve the linear equation and use a parametric representation for the solution. We have 2 times x sub 1 minus 4 times x sub 2 equals 12. So the first step is to solve this for x sub 1 or x sub 2. Let's go ahead and solve this for x sub 1. So our first step is to add 4 times x sub 2 to both sides of the equation. That would give us 2 times x sub 1 equals 12 plus 4 times x sub 2. Now let's go ahead and divide everything by 2. So now we have x sub 1 equals 6 plus 2 times x sub 2. Because we have two unknowns in one equation, we have one free variable, so we should recognize that we are going to have an infinite number of solutions, and because of this, we'll introduce a third variable, or a parameter, which we'll assign to our free variable. Let's let x sub 2 be our free variable. Let's also let t be any real number. And since we're letting x sub 2 be our free variable, to represent our solution parametrically, we're going to let x sub 2 equal t, which means x sub 1 would have to be 6 plus 2 times t, replacing x sub 2 with t. So this is one way to represent the solution to our linear equation parametrically. And I say one way because the parametric representation of a solution is not unique. So just to illustrate this, let's say we let x sub 1 be our free variable. And again, we let t be any real number. But in this case, to form our parametric representation, let's let x sub 1 equal t. And therefore, using this equation here, the second equation would be t equals 6 plus 2 times x sub 2. And now we'd have to solve this equation for x sub 2. Let's go ahead and do that. We'd subtract 6 on both sides. That would give us t minus 6 equals 2 times x sub 2. Divide everything by 2. We'd have 1/2 t minus 3 equals x sub 2. So we could represent the same solution parametrically as x sub 1 equals t and x sub 2 equals 1/2 t minus 3. These are two different ways to represent the solution parametrically. Often in algebra class, we are asked to graph our linear equations, and we could do the same here using the parametric equations rather than the original equation. Let's go ahead and do that using the solution expressed using these equations here. So we'd make a column for t, which can take on the value of any real number. then we have x sub 1, and then we have x sub 2. Well, the first thing we should recognize is that whatever t value we select, it's also going to be the value of x sub 2. And then since we know that x sub 1 equals 6 plus 2 times t, we can substitute the same values for t to get the values for x sub 1. Every x sub 1 and x sub 2 forms an ordered pair, which represents one possible solution, which we can graph on the coordinate plane. Again, thinking of the x-axis as the x sub 1 axis, and thinking of the y-axis as the x sub 2 axis. If we plot these 5 points, we can sketch our line, which is another way to represent a solution to a linear equation with two unknowns. Let's take a look at a second example. Notice here we have one equation with 3 unknowns, and 3 minus 1 is equal to 2, so here we'll have 2 free variables, which means we'll introduce 2 parameters or 2 new variables to represent the solution parametrically. Looks like it's going to be easiest to solve this for x, so we would add 2y to both sides as well as subtract 3z. So we would have x equals 6 and then plus 2y minus 3z. So in this case, let's let y and z be our free variables. So we introduce 2 parameters or 2 new variables. Let's let s be any real number and t be any real number. So we'll go ahead and let y equal s and z equal t, which means x is going to be equal to, using this equation here, we would have 6 plus 2 times y, but y is s, so plus 2s, minus 3 times z, but z is t. So this would be the parametric representation of the solution to our linear equation. And because we have one equation with 3 unknowns, the graph of this would be 3-dimensional, or it would be a plane in space. Let's go and show how we would do this using the parametric equations. Again, we'd start with a column for s and a column for t, which we'd let be any real numbers that would be convenient to perform the calculations. And since s equals y, this column and this column are the same. And since z equals t, this column and this column are the same. And then we're left with finding x by performing substitution for s and t, which has been done here. Notice here each solution consists of a value for x, y, and z, so we have ordered triples, which would be points in space, which as we see here would be a plane graphed in space. Okay, I hope you found this helpful.